Hello my dear class 10 students, how are you all? I hope you are doing amazing. In this video we will be doing a quick summary of the chapter carbon and its compounds. So let's start with carbon. What is carbon? It is a non-metal. What is the atomic number of carbon? It has an atomic number of 6. Electronic configuration have 2, 4. Mass number 12, right? The valency of carbon is 4. Carbon cannot lose 4 electrons and it cannot also gain 4 electrons, right? It cannot lose 4 electrons and form a duplet. Why? Because losing those 4 electrons is not energetically favorable, and also gaining 4 electrons mean 6 protons will have to deal with the 10 additional electrons. 6 protons will have to deal with the 10 electrons, right? And obviously there is an imbalance of power, and because of that the compound, the atom will not be stable, right? That's why it does not form anion or cation. What it does, it shares its 4 electron with other atom, right? And forms a covalent bond. Yes, my dear kids, bond formed by sharing of electron, that is called a covalent bond. Carbon forms a covalent bond with other atoms. Now let's discuss what this covalent bond is. Covalent bond is a bond formed by the sharing of electrons. When metals and non-metals combine, we get an ionic bond because one is donating electron and the other is accepting electron. But when non-metal and non-metal basically both want to, what do they want to do? Both want to gain electron. So what they do, they cannot gain electron from each other. So they say, let's sit down buddy, we will share these electrons, and that's why they form, that's how they form covalent bond, right? For example, HCl, it is a covalent bond. HCl is a covalent bond. So one electron from hydrogen, and chlorine needs only one electron to complete its octet. So that's why it does share its one electron and forms this covalent bond. Similarly, carbon dioxide. This is the structure of carbon dioxide, right? So oxygen shares its 2 electrons. Carbon shares its 4 electrons with the 2 oxygen atoms, and we get carbon dioxide, right? Now what are the different type of covalent bonds? There are 3 types. Single covalent bond, when only 1 electron is getting shared. Double covalent bond, when 2 electrons are getting shared. Triple covalent bond, when 3 electrons are getting shared. Now what are the properties of these covalent compounds? Covalent compounds are those compounds that have the covalent bonds, right? They have low melting and boiling point. Why? Because covalent bond is weak in nature. They are poor conductor of electricity. Why, ma'am? Because they do not have any free ions or electrons. They are soluble in organic solvents like benzene, hexane. They are not soluble in polar solvents because there is no ions on them. There is no charge present on them. Okay? No plus minus. Clear? Allotropes of carbon. What are allotropes? So allotropes are different structural forms of the same element in the same physical state. So basically they are made up of the same element, but they have different structural forms. For example, we have 3 allotropes of carbon. Start with diamond. It is a crystalline allotrope of carbon, right? In diamond, each carbon unit is connected to 4 other carbon units, right? This is diamond. Each carbon unit is connected to 4 other carbon units, right? There is no free electrons there, so that's why they are bad conductor of electricity, but they're extremely hard because this is a 3D arrangement, right, of all the carbon atoms, and it is extremely hard. Next is graphite. Graphite is this grayish black opaque substance which is actually soft and very slippery to touch. In graphite, this is the structure of graphite, right? It is a hexagonal array structure. Each carbon atom is bonded to 3 other carbons. With this carbon, look at this carbon, it is bonded to 1, 2 and 1, 2 and 3 other carbons, right? So there is one free electron there. Due to this one free electron, they conduct electricity. They are good conductor of electricity. Clear? Plus these layers, they are far apart from each other. There is very weak interaction, very weak force of attraction between these layers, and that's why they are very soft and slippery to touch. Okay, whenever you put little bit force on that, these layers will slide over each other, right? And that's why they are very soft and slippery to touch. Next is Buckminster fullerenes. It is called C60, right? It is also an allotrope of carbon. So it is a newly discovered allotrope of carbon. Carbon atoms, they are arranged in form of a football. This dome, geodesic dome. It is in the form of this geodesic dome, and this dome was similar to a building in America that was designed by an architect called Buckminster fullerenes, and that's how it got its name, right? They're neither too hard nor too soft. Next is hydrocarbons. What are hydrocarbons? These hydrocarbons are organic compounds that are made up of two kinds of atoms, carbon and hydrogen, that have carbon and hydrogen. Now there are different type of hydrocarbons. We have saturated hydrocarbons. What are saturated hydrocarbons? Hydrocarbons having only carbon-carbon single bond are called saturated hydrocarbons, right? All the carbon-carbon bonds are single. That is called saturated hydrocarbon. For example, alkanes are saturated hydrocarbons, right? The general formula of alkane is CnH2n plus 2, like methane, ethane, propane, butane. Clear? Then we have unsaturated hydrocarbons. What are unsaturated hydrocarbons? Hydrocarbons that have double or triple bond. That have double or triple bond, right? They have at least one double or triple bond. Also single bond, but they have at least one double or triple bond present in the compound. That are called unsaturated compounds. Clear? For example, alkenes and alkynes. Alkenes may you have example ethenes, and in alkynes you have ethyne. Clear? In cycloalkenes, third type is cycloalkenes. So basically cyclo means a cyclic ring will be there. So they are similar to alkanes. But instead of the straight line structure, they have a ring like structure, cyclic ring like structure, right? For example, cyclobutane, cyclohexane, cyclopentane, right? So the general formula is CnH2n. Clear? It is similar to that of alkenes, CnH2n, and alkynes have a general formula CnH2n minus 2. Homologous series. Now homologous series is a series of organic compounds that have same functional group, same general formula. Each successive member differ by a CH2 unit. They have same chemical properties, similar chemical properties, but they show gradual change in physical properties. Why? Because of the change in molecular mass. As you are going down or as you are moving in the homologous series, each successive member differ by a CH2 unit, that is 14 atomic mass unit. For example, these all are your example of homologous series: alkane, alkene, alkyne, haloalkane, alcohol, ether, aldehyde, ketone, carboxylic acid. These all are the examples of homologous series. Now, how do you name hydrocarbons? How do you name the carbon compounds? So the rule is simple. There are two methods to name it: IUPAC nomenclature, IUPAC nomenclature, or you can say common names, right? Common names are given by scientists or due to their general use by the general public, right? And the IUPAC name is defined by a set of rules that is given by IUPAC itself, right? So when you are writing the name, so you need to know some things, a few things. There is a prefix. Firstly, you write the prefix, then you write the word root, then you write the primary suffix, and then you write the secondary suffix. These are the word root depending on the chain length. You need to remember only till 9. That is more than enough. So 1 carbon meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. No one will be asking you more than 10, right? So firstly you write the substituent you have. Firstly you write the prefix or the substituent that you have. Then after that write the word root. How many carbons are there in that particular carbon chain? And then write the primary suffix if you have other functional groups, and then write the secondary suffix. Let me give you some example of the suffix actually. For example, in case of alcohol you have the suffix ol. In case of ketone you have the suffix on. In case of aldehyde, you have the suffix al, carboxylic acid, oic acid, and alkane, ane. For alkene, you have ene, and for alkyne, you have yne. Okay? I hope that is clear. Chemical properties of carbon compounds. Next, carbon compounds show some chemical reactions, right? For example, combustion. When you add oxygen to a carbon compound, it combusts. It produces carbon dioxide, water, and heat, lots of heat and energy. That is combustion. Second is oxidation. So oxidation means addition of oxygen in a controlled way, right? Heat or light may or may not be produced, but in combustion you add oxygen in an uncontrolled way and heat and light is always produced, because that is combustion. Oxidation of, for example, the oxidation of ethanol will give ethanoic acid, right? And some good oxidizing agent we use like alkaline KMnO4 or acidified K2Cr2O7. Then the third reaction is substitution. Substitution means when firstly these reactions are given by saturated compounds in which one hydrogen is replaced by some other compound. So for example, it already have 4 bonds. Any saturated compound have single bonds, right? It has all the 4 bonds made. So any other atom will come and will replace this atom and take its place. That is substitution. It is shown by saturated compounds. Clear? addition reaction. It is shown by unsaturated compounds that have double or triple bond. So there is a need, or there is a requirement for the addition. There is a possibility where you can add any other atom. Okay, there is no atom getting replaced here. These two hydrogens, four hydrogens will be there, but in place of this double bond, two additional hydrogens gets added. This is an important reaction, hydrogenation of alkenes. What does it give? It gives alkane, right? And it is one of the majorly used industrial process that is used to convert unsaturated compounds into saturated fats, unsaturated oils into saturated fats. Clear? Yeah, one more thing, oils are unsaturated compounds and fats are saturated compounds. Now the chemical properties of ethanol and ethanoic acid. Ethanol is an alcohol, CH3CH2OH, right, or C2H5OH, both are correct. Ethanol shows combustion. So when you add oxygen to ethanol, it burns and gives carbon dioxide and water. It burns with a very clean flame, right? It burns with a very clean flame, so you cannot even see it with your open eye, with our eyes. Next is sodium. How does ethanol react with sodium? When ethanol reacts with sodium, it produces sodium ethoxide and hydrogen gas is evolved, right? Oxidation of ethanol will give ethanoic acid, and dehydration of ethanol. When you dehydrate ethanol, that is, you add hot concentrated sulfuric acid at around 443 Kelvin, ethanol gets converted into ethene. Dehydration means removal of a water molecule happens and we get ethene. Ethanoic acid, it does react with sodium and form sodium ethanoate, and it reacts with sodium hydroxide also, again salt plus water. In case of reaction with sodium metal, it produces hydrogen gas. When treated with sodium carbonate or sodium bicarbonate, ethanoic acid gives again salt plus carbon dioxide gas is evolved. This is used as a test to check the presence of ethanoic acid. Esterification, simple. When ethanol and ethanoic acid combines in acidic medium, what happens? We get an ester, right? And if you reverse this reaction, it is called saponification reaction. That is, if ester is treated with a base, we get acid and alcohol. We get the acid and alcohol back. That is saponification reaction. Clear? These two are very important regarding your exam point of view. Now, how do you distinguish between ethanol and ethanoic acid? So there is one litmus test. Again, ethanoic acid is an acid. It will turn blue litmus into red, but ethanol, there will be no effect. Similarly, reaction with sodium bicarbonate, when ethanoic acid reacts with sodium bicarbonate, it evolves carbon dioxide gas. There is a brisk effervescence of carbon dioxide gas, but ethanol does not give this reaction. Clear? Similarly, if somebody asks you to differentiate between saturated and unsaturated compound, which test will you use? You will use the bromine water test. Bromine water test. We will use the bromine water test. We will use the bromine water test. Now, what is this bromine water test? According to this bromine water test, what happens when an unsaturated compound, when you have an unsaturated compound and you add bromine to it, bromine water to it actually, if you have an unsaturated compound and you add bromine water to it, what will happen? It will lose its color. Bromine water is reddish brown in color. It is reddish brown in color. It will lose its color when treated with the unsaturated compound. But when you treat it with a saturated compound, it will retain its color. That is the bromine water test to distinguish between unsaturated and saturated compounds. Soaps versus detergent. What are soaps? Soaps are sodium or potassium salt of long chain carboxylic acid. They only work in soft water, right? And they have two parts. Actually, soap and detergent both have two parts. They have a hydrophilic head. This is the hydrophilic head and a hydrophobic tail. Hydrophilic means water loving head and hydrophobic means a water fearing tail, right? Detergents, they are ammonium or sulfonate salts of long chain carboxylic acid. They work in both soft and hard water. Now, what happens in hard water? Hard water have these magnesium and calcium ions, and due to the presence of these magnesium and calcium ions, they form this compound, this insoluble product called scum. When soaps react with when you treat soap with hard water, what happens? These magnesium and calcium salt that is present in the hard water, it forms an insoluble product called scum, and that's why it is not used in hard water. Next, what is the missile? What is missile? Missile is this formation happens after when soap molecule is applied on a dirty or greasy particle, right? So what happens, you have a dirt or oil particle, around that these soap molecules, these are the soap molecules, they align themselves in such a way that the hydrophobic part is towards the oil particle and the hydrophilic part is outside towards the water, right? This is the missile. They surround this dirt particle, oil particle, right? And when you add excess of water and agitate this cloth, this will get washed out, right? And that's how you get clean, nice clothes.